Let's find all asymptotes of the rational function. We'll start by finding the vertical asymptotes. To do that, we first need to factor the numerator and denominator. The numerator, notice, is a difference of cubes, so we can factor as x minus 2 times x squared plus 2x plus 4. And in the denominator, we'll factor the quadratic. Two numbers that multiply to negative 10 and add to 3 are plus 5 and minus 2. Notice that we have a common factor in the numerator and denominator, so that's going to reduce out. And looking at the resulting denominator, we'll set it equal to 0, and we get x equals negative 5. This is the vertical asymptote. Remember that the factor that reduces out, the x minus 2, indicates that there's a hole at x equals 2. That is not a vertical asymptote. To find the horizontal asymptotes, we compare the degrees. Since the degree of the top is 3 and the degree of the bottom is 2, the top has a higher degree, there's automatically no horizontal asymptote. Next, recognize that the top is one more degree than the bottom, so we can find the oblique asymptote. We can't use synthetic division here because the denominator is not linear, so we have to use long division. X squared plus 3x minus 10 is the divisor, and inside the house we write the numerator, the dividend. X cubed plus 0x squared plus 0x minus 8. And from here, we take the first term and divide it by the first term. If you want to, we can do that off to the side. X cubed divided by x squared is x. That goes in the quotient. Then we distribute. X cubed plus 3x squared minus 10x. We'll then subtract that. The x cubeds go away. We're left with negative 3x squared plus 10x, and then we drop down the negative 8. Then we repeat that process. First term divided by first term. Negative 3x squared divided by x squared is negative 3. So that goes up in the top. And at this point we can stop because we'll just get a remainder which we're going to ignore anyway. So the oblique asymptote, we just simply take this expression and put a y in front of it. Y equals x minus 3 is the oblique asymptote, also known as the slant asymptote. Up next, we have another rational function. Let's start by finding the vertical asymptotes. To do that, we need to factor. So we will factor the top and the bottom. And since these are quadratics where a is not 1, we need to use the AC method. So looking at the first quadratic, the numerator, AC is negative 30. We need two numbers that multiply to negative 30 and add to negative 15. That will be negative 15 and 2. So rewriting the quadratic, we have 5x squared minus 15x plus 2x minus 6. Now we can factor. Pull out that GCF. We're left with x minus 3. Pull out the next GCF. We're left with x minus 3. So now continuing to factor, x minus 3 times 5x plus 2. We'll put that in the numerator. And then for the denominator, again, we need to use the AC method. AC is -6. Two numbers that multiply to -6 and add to -5 are -6 and 1. So 2x squared minus 6x plus x minus 3. Pulling out the GCF, we get 2x times x minus 3, then 1 times x minus 3. Continuing to factor, we get x minus 3 times 2x plus 1. We'll put that in the denominator. Notice now that we've got it in factored form, we can reduce. X minus 3 goes away. That's going to be a hole in the graph. We look at the denominator now and set 2x plus 1 equal to 0. 2x equals -1. X equals -1/2. That is our vertical asymptote. To find the horizontal asymptote, we compare the degrees. Notice the degree of the top and the bottom are both 2, so we compare a ratio of the leading coefficients. So the horizontal asymptote is a ratio of the leading coefficients. Y equals 5/2. We do not look for an oblique because we have the horizontal.